Hey guys, welcome to day 4 of solving LeetCode daily challenges. Today's problem is least number of unique integers after k removals. So the given problem is given an array of integers array and an integer k. We have to find the least number of unique integers after removing exactly k elements. Let's say there are the given elements 5, 5 and 4 and we have to remove one element. After the removal, there should be minimum number of unique integers. Let's say we remove 5 here, then the unique elements will become 2, right? So we can't remove 5 and the next integer will be 4. If we remove this 4, we will get only one number of unique elements. So we have to choose which element we have to remove so that we can get least number of unique elements. Let's take a simple example. Okay, so let's take an array 4, 2, 2, 5, 1 and 7. Let's take this example and here k can be equals to 3. So let's think which element we can remove. Let's say if we remove this element and this element, the number of unique occurrences or elements will be 1, 2. So 2, 7 will be remaining and number of unique elements can be equal to 2. Now let's say what is the approach we can use. First we can write the frequencies of the array elements, like 4 is repeating once, so 1, and 2 is repeating twice, so we can write as 2, and next 5 is repeating once and 1 is repeating only once, so 1, and 7 is repeating once, so 1. So we wrote the number of occurrences. Let's say it is a frequency. We wrote the frequency list of the given array. It's so we can do which removal first. Let's say we can remove the least occurrencing element from the array. Let's say we are removing this, or this. So once. So but k is given as 3. Only 3 elements can be removed. So we can say we can remove any 3 of this. Let's first sort the given frequency array. So it can be as 1, 1, 1, 1 and 2. Let's store the number of unique variables here. That is unique variables can be length of the frequency, that is equals to 5 at first. And now for I comma c, let's say I will be the index and c will be the values in the frequency. First let's take k equals to let's remove this first occurrence, that is we are removing the first index, right? So let's say 3 minus 1 will be equals to 2. Here we can say that what if we remove till here, like if k is less than 0, it might be minus 1, minus 2, minus 3 and so on, right? Till the sum of these frequencies. So it can be what, in this case we need to return the number of unique elements left in this frequency. Let's do a simple approach, like now I have removed the first element, right, in only one occurrence. So k will be 2. Let's check if k is less than 0. So k equals to 2, it's not less than 0, right? So we'll just move to the next element. Now k can be c will be here, right? So k equals to 2 minus 1, that can be equals to 1. So now let's check the given condition, that is k less than 0 or not. This is the condition we need to check every time we remove the occurrence of the element. So let's check if it is true or not. It's not true. So let's move to the next element, that is next index. C will be here. So k will be 1 minus 1, that equals to 0. Let's check for the given condition. Now k equals to 0, but it's not equals to 0, right? So we'll move to the next element now here. let's say what if k is not what if this element is 2 here, then it can be like k will be -1. At this case we can check if the condition is met or not. Now it's not 2, so we'll move to next element and check for k equal, then k becomes to 0 minus 1, that is value of the frequency, then k equals to -1. Here the condition is met. So in this case what we'll do, we'll take the length of frequency. What is the length of frequency? That becomes u, right? Let's say length of, we'll just, if it is met, we'll just return u minus the particular I, that is index. Let's say 0, it's 1, 2, 3, 4. What is the frequency here? It's 3. So we'll minus the 3 and it becomes 5 minus 3, that equals to 2. This 2 will be returned. Let's move to the code part. So first we'll take the frequencies, like f equals to we'll take counter of array of, we'll take the values of the frequencies, right? So we'll take only values. Here it will be list of counter of the frequencies. As we are sorting in this case, as we are sorting the frequencies, we'll just directly take list of sorted of the frequencies. Okay. Then let's take lu equals to length of the frequency, and for I comma c in enumerate of f, okay, let's say k minus equals to c, and let's check if k is less than 0. Now if it's less than 0, we'll just return length of the frequency, or you can say u minus particular I, else we'll just return 0. Let's check if the code runs fine. Yeah, the code runs fine. Let's submit it and see if it's correct for every test case possible. Yeah, it is. Okay, so let's move to the next approach. First we'll talk about the time complexities. Like in the sorting, we have used the time complexity of order of n log n, as we are sorting the array with length of array elements in it, and the space complexity will also will be equal to order of n, as we are storing n length of array number of elements in the frequency. To optimize the sorting way, let's say we have to not we should not sort elements here, not sort the elements directly. Then we can move to the next approach, like we can use a heap here, heap queue. Let's, what is the approach? Let's see it. So let's take an example for 2, 2, 1, 5 and 7. We'll write it is the array, and let's write the frequencies as 1, 2, 1, 1 and 1. Let's say the length of the frequency equals to 5 here, right? Now we'll take a we'll heapify it. The heap of the queue will become as f. So 2 will be at the least. We'll write a min heap. So in this case, we'll keep the minimum elements at the top and maximum elements at the bottom. So first, we'll take a counter variable as c equals to 0. Let's say the number of unique elements equals to pi or n. Now let's check if this frequency is not empty. It's not empty. So we'll take out the first element and add it to c. Now c will become 1 and number of frequencies will remain same. And now let's say we'll pop out the second element and c will become 2 now. We'll check in every case if c is greater than k or not. if it is greater than k, that is we should not uh, exceed the number of k removals. So we'll check for this condition in every case. Now if this condition is met, we'll just return u plus 1. Now as we remove two elements here, the number of unique elements or length of the queue will be 4 and then 3 here. Let's take out the next element and increment the c value to 3, that is value, and the length of the min heap will be equals to 2. Let's check if this condition is met or not. 3 is greater than 3. It's not true. In actually it's false. So we'll just take out the next element and increment the c value by 1, that is equals to 4. In this case, 4 is greater than 3, right? So we'll just return u plus 1 and u will become 1, that is length of the min heap will become 1, and we'll just return 1 plus 1, that equals to 2 as answer. Let's check the time complexity here. The heapifying of the array will be n log n, and space complexity will be like n. Let's do the code part. Let's say f equals to list of counter of array dot values. We are taking all the frequencies from the array elements. So next we'll take heap q dot heapify of the particular frequencies. First we need to import heap q. Now let's heapify it and let's take c equals to 0, that is number of elements removed. Now let's do while frequency, or the frequency is not empty. We'll just take out c plus equals to heap q dot pop of, okay wait, heap pop of the f, means your first element will be popped out, and then we'll check if c is greater than k. If it's greater than k, we'll just return the length of frequency plus 1, and if it's not met, or like we have removed all the elements from the frequency, then we'll just return 0 here. Let's check if the code runs. Yeah, the code runs fine. Let's submit it and see if this possible approach is true. Yeah, it's running fine. Let's see how to minimize the space complexity, as here the space complexity and time complexity will be like order of n here in this case, but in this case the frequency, I mean the time complexity will be order of n log n. So to minimize this approach, we'll just not use sorting, and let's see how to do it. Okay, so let's take a frequency of the array can be 4, 2, 2, 5, 1 and 7. First we'll take the frequencies of the array. Let's say 1, 2, 1, 1 and 1 is the frequency. Let's take the frequencies of these frequencies. Let's say 1 is repeating for 1, 2, 3, 4 4 times, and 2 is repeating for 1 time. Then the frequency array becomes 4, 1. And now let's do, like, it will be my count of frequencies. How many times can we remove the element? Let's say we can remove at maximum, we can remove k by I times. Let's say k equals to 3. So we can take I can be like 1, 1, 2 in this case, right? So if we take k by I or k by 1, we can remove the element 3 times at max in the frequency array. And then now we'll do the condition like till this k is greater than I, will just reduce the k value. That is, while k is greater than I, will reduce the k value to k minus I into number of removals. Let's say if this k is less than I, we'll just return the number of unique elements. Okay, so in this case, the number of unique elements equals to 1, 2, 3, 4, and 5 as length of the frequencies. So now we'll do a loop like we'll say for I in range of 1 comma length of this count frequencies. We'll check if this k first we'll check if this k is less than I. If it's less than I, we'll just return U. Now let's see if k number of removals R can be equals to minimum. We have to take the minimum number of removals. So we'll take minimum of k by I, comma the frequency of I. Let's say with a given example, let's take this count of frequencies array. First I will be equals to 1 and count of frequencies like C can be equals to 4 here. Let's say R equals to 3 by 1, minimum of 3 by 1, comma this frequency that is 4. Here we'll get 3 comma 4. We'll take this particular 3 in this case, and now the number of removals equals to 3. And let's check if this condition like k will now become k minus I into the particular removals, that is 3. 3 minus 3. In this case, the number of k becomes equals to 0 in this case. So the number of unique elements now will be equals to the number of unique elements 5 minus number of removals, that is equals to 3, equals to there are 2 unique elements remaining. In next case, let's take I equals to 2 and k equals to 0. We can see that k is less than I. So we'll just return U, that is 2 in this case. Let's do the code part. Okay, so let's move to the code part of reducing the time complexity of sorting. So let's take f equals to the list of counter of array dot only values, and next we'll take n equals to, let's say, length of the array, and number of unique elements equals to length of the frequency array. Let's take a count of frequency array, that is equals to, first when you initialize it with zeros, into it has n plus 1 number of elements in it. Let's say for I in the frequency, that is we are taking the values of the unique integers or occurrences of the unique integers. Let's say if for I in f, cf of I is incremented to 1 every time we encounter a frequency. Let's say we have the frequency as 1, 1, 2, 1 and 2. Every time we encounter 1, the count of frequency of 1 will be incremented. So now let's say the count of frequency is done. We got the array. Now for I in range of 1 comma n plus 1, that is length of the count of frequency array. Let's see if number of removals will be equals to minimum of k by I, that is maximum number of removals we can do from an array will be equals to k by I times, that is the number of removals to be done by the particular indexes, comma count frequency of 1 I. And now let's take k will be reduced to I into r, that is number of times we are removing the elements from the frequency array or array, will just decrease the k. And now we'll update the number of unique elements to u is decremented with number of elements removed. Let's check if k is less than I. If it's less than I, we'll just return u. If all the elements are removed, we'll just return 0 as the default. Okay, so the code runs fine. Let's submit it and see if this approach is correct. Yeah, it's submitted successfully. So let's see the time complexity in this case. Here the time complexity of the frequency will be equals to like time complexity equals to order of n, and in this case it is order of n plus 1, or it may be order of n equals n itself. And in this for loop the frequency or sorry, time complexity will be equal to order of n. So overall the time complexity is reduced to order of n from order of n log n. But the time space complexity here will be order of n plus k or order of n. To store the values of f, cf and the frequencies arrays, we'll just have the space complexity of order of n at max. So that is it for today guys. Meet you tomorrow. Hope you like this video.